Ever wondered how AI could master games not just by learning from humans, but by teaching itself from scratch? Today, we're exploring a breakthrough experiment where AI agents tackled Settlers of Catan, a strategy game renowned for its complexity. This isn't just about dice rolls and settlements. It's a test of resource management, negotiation, and long-term planning. Let's unpack how these AI systems evolved, and why this matters for the future of machine learning. Catan's challenge lies in its hybrid nature. It's a mix of probabilistic outcomes, dice rolls, strategic resource allocation, and social dynamics, trading with opponents. Unlike chess or Go, where perfect information is key, Catan forces players to balance uncertainty with adaptability. For AI, this means grappling with partial observability, non-deterministic environments, and the need to optimize for multiple conflicting objectives, like maximizing resource production while maintaining diplomatic ties. Researchers tested 4 AI agents, each representing a different approach to learning. The base agent was a raw novice, using a simple heuristic. It evaluated the game state, resources, board positions, turn order, and selected moves at random. Think of it as a neural network with no training, just a blank slate. Its performance? Predictably poor. It couldn't distinguish between a winning move and a catastrophic mistake. But humans don't learn by guessing. The structured agent introduced rule-based strategies, like prioritizing resource diversity or targeting high-yield hexes. These rules were manually coded by experts, acting as a cheat sheet for the AI. While this improved performance significantly, it still relied on human intuition. The AI couldn't adapt to novel situations outside its predefined rules, a critical limitation. Now here's where it gets revolutionary. The PromptEvolver and AgentEvolver didn't just follow rules, they rewrote them. Imagine an AI that plays thousands of games, analyzes its losses, and iteratively refines its strategy. This is where evolutionary algorithms and reinforcement learning collide. The PromptEvolver functions like a self-improving prompt engineer. It generates and tests different instruction sets for the AI, such as prioritize brick in early rounds or aggressively trade for ore. If a prompt leads to a win, it's retained. If not, it's discarded. This process mimics natural selection, with fitter strategies surviving. The AgentEvolver goes deeper. It doesn't just adjust instructions, it evolves the AI's architecture. Using techniques like Neuroevolution, it modifies neural network layers, activation functions, or even the way the AI processes game states. It's like giving the AI a toolkit to redesign its own brain, based on past performance. What's the end result? Agents that outperform human-designed strategies, discovering counterintuitive tactics no programmer could predict. One evolved agent, for instance, prioritized early-game expansion over resource accumulation, a move that initially seemed risky but paid off in long-term dominance. This experiment isn't just about gaming. It's a blueprint for AI that learns autonomously in real-world scenarios. From logistics to climate modeling, systems that adapt without human intervention could revolutionize fields where rules are fluid and outcomes uncertain. The next frontier: teaching AI to collaborate, negotiate, and even deceive, skills as critical in Catan as they are in human society. So what's the takeaway? The future of AI isn't about programming smarter machines. It's about creating systems that learn to think in ways we've yet to imagine. Stay curious, and let's keep pushing the boundaries of what machines can achieve.